right, this is Andy McNeil at Free Arkansas, and today I want to tell you a scary story for Halloween, a real scary story that happens to be potentially our future. So what I'm going to do today is I want to go over, I guess you might say, a Substack article that was written by a guy named Leopold Aschenbrenner, who's a young guy that's deeply involved in AI. And it's sort of a white paper of what our future could look like. And I want to walk through it and just give maybe a layman's perspective if I could. But I think one of the things we all can say is that the AI race is on. I think we see it all around us. There's evidence everywhere that it's here. And and so what is this race all about? And I think we're moving toward where each iteration of AI gets smarter and smarter. And at some point we'll reach what we call AGI, which is artificial general intelligence, which is basically the equivalent of a very, very smart human being. And we're going to be able to replicate that, And so, we see these power plants being built out in various places. We see that Google even this week bought a power plant in Illinois. Projects like Stargate in Abilene, Texas, are $100 billion investment in AI that's going to consume over a gigawatt of power, which is roughly the size of a large city. China, over the last, decade, has put in enough power plants that equal the whole United States grid, while our grid is basically remain the same. So there's a lot of interesting things that's gonna happen, and so what we don't really know is where is it all going to go. So what's it going to look like later on? I remember looking at being at other times, in my life where we're looking at other things that are transforming in the pace of those. So how the internet rolled out and what people said in the 90s about what was going to happen with websites, who was going to be replaced, how the world was going to change. A lot of what we said back in 96 and 95 and, the late 90s was wrong, but a lot of it was right. And there was a lot of things that for sure happened that we weren't intending. And if nothing else, we created a massive market. That's the same with cellular technology, the same with the way that railroads rolled out. And so there's lots of examples we can look to see how scaling works. So, but first, let's just talk about, what we've sort of seen out in the marketplace. And let's just talk about how it's scaled so far. Because one of the ways that we can look at where we're going to go is simply look at the line of where we've been. Right? We can look back and say how we've leapt up over a period of time. So today, most people, if you go on and log on to ChatGPT, you get ChatGPT version 5. But there was earlier versions of ChatGPT, and each iteration, it gets smarter. So when we look at ChatGPT 2, we might say that it was like a preschooler. What it did was super impressive. It could see and notice like a picture and say, that's a cat. It could string together sentences, right? But it also had a lot of mistakes. Maybe it couldn't count very well. As we migrate from there, and then we get to ChatGPT 4, we might say is like a smart high school student. It was able to pass standard tests, right? It can pass the SAT, the LSAT, the MCAT. It's like it's amazing. Right, that it can actually do all these different tests, and ChatGPT 5 for anybody that really works with it well, we're seeing it change all the time in terms of how people are using it. We're using it in businesses to automate certain functions. More and more people rely on it. I've watched many people do things like this: take a picture of something and just ask ChatGPT what it is, and it's amazing what it can do. And so. But there's things about how it scales that we all have to understand, because to understand these building blocks are what really happens in terms of how we go from where we are today, to the future. So there's aspects, you might say. So one is just pure computers, the number of computers, the computing power of those computers. So that's an element of what happens. The next piece is what we're doing on algorithms. So how algorithms are written is a really important aspect to how fast and how well and how accurate the large language models actually work. And lastly, there's ways within these things to unlock, let's just say, latent capabilities. There are sort of tools that we can add on that provide, handholds and scaffolding, you might say, to improve um, the way these models actually work. So where the algorithms, you might say, impact efficiency, these tools impact effectiveness. Um, so if we can imagine that what happens today is that we've got some of the smartest people on the planet, a lot of times in startups, or at least they started off in startups, and of course in huge tech companies today. And I want to come back to this point. This is why I brought it up, because I want to talk about what I think is going to happen in the future related to this. But they're pining away at improving these algorithms, right? So that's one of the things they're doing is they're going from ChatGPT 4 to ChatGPT 5. They're creating these handholds and these tools that they stack onto all of them. But as we go forth to the future, what's going to happen is we're gonna invest substantial capital, and that substantial capital is going to solve some of these things to scale. And what we can imagine is this: is that we're going to be going after super intelligence, because we can see on this line that at some point, the next iteration, it's going to be the smartest human that ever existed. And you're going to be able to multiply that person times, 1,000,000 times. And they're going to be able to work 24 hours a day, every single day of the week. And what we're going to do is we're going to have them work on AI research themselves. They're going to be the ones that are looking at improving these algorithms, putting together these handholds. And when they start doing that, we're going to see huge increases in what these systems can do. Now, one way to sort of think about a large language model is that it's scraping everything that's out there, right? And we're going to come to a point where what's scraped is literally everything. Every book, every piece of art, every piece of music, every website, all of it. And you might say, well, okay, you hit this data wall. What next? What happens next? And and right now, what I would point out is we're in a world where a lot of that data that's out there, a lot of it's benign, right? It's just a book that was written, etc. But more and more, we're going to be protective of our data, because the data and the algorithms and these tools are going to be the unlocking moves that create the super intelligence. And we have a lot to worry about whose hands these things get into. So when we hit a data wall, what's going to happen is these tools are going to start creating synthetic data. And what that means is they're going to start running simulations on all sorts of things. Just think about simulating genetic research, simulating algorithms, simulating, medical research. So it's going to, so all of these fields are going to expand rapidly. And that synthetic data is going to be incredibly proprietary, because he who has the synthetic data also has the other things, will have, all the power, so we're going to see this rapidly change. Now, how fast we see it change is dependent on what the spending is on the scale up. And so today, what I would point out is you look at something like this, you look at, say, the Stargate project in Abilene, Texas at $100 billion, huge investment. But I think what's going to happen in the next year or so is you're going to see $1 trillion cluster, where somebody puts $1 trillion to work. And the Abilene facility is going to consume over 1 gigabyte of power. Now, the United States consumes 28 gigabytes a day. So we consume a lot more than 1 gigabyte over a year. But, 1 gigabyte is like, the size of a 70, of a big city, and so when we talk about $1 trillion data center, we're talking about something that could consume up to 20% of the power in the United States. So if we're going to build out 1 or 2 or 10 of these facilities, whatever it looks like, they're going to consume a monster amount of power. And, that's going to require, a number of different things. So we do have some limitations on the speed, though. So, will we get there with the computers can, like anything else, we can sometimes grab all the low hanging fruit, but that last 5% is super difficult. So things like that are going to hold us back. But the opportunities for where it's going to go are going to be, they're going to be too enticing. And so, because we're going to have where it's going to go with super intelligence is it's going to have extraordinary AI capabilities. So there's going to be an explosion of what AI can do. We're going to solve for robots. We're going to, accelerate science. We're going to see an economic and an industrial sort of explosion. It also is going to have military consequences because he who has this power is going to be able to control other people. This is going to be, so you have to win this. And you'll be able to overthrow governments because you'll be able to have all sorts of unbelievable powers when you've got this. So what I'd point out, I think, when you think about it in this context, it doesn't really make sense for startups in San Francisco to drive this process because this is really a national project. When we look at other things that were national projects, the Manhattan Project, the Apollo Project, these things at the time, they consumed, a decent amount. It's a fractional, but of the GDP of the United States. So when we look at the build out of the cellular industry, there was $1 trillion spent on putting lines all over the United States to build out for that cellular industry and the internet backbone. There's been trillions of dollars globally spent on the green infrastructure. So it makes sense that we're going to continue to spend a ton of money, on this. And I think it's in the national security interest of the United States, that we win, and so I think that, that's what's at stake. The preservation of the free world, you could argue that's it's at stake because there's things that, we're not really good at, we're not really good at security. Right. And so the reality is that when we're talking about stealing algorithms and it's really algorithmic weights. So what that means, it's the variables inside the algorithms, but these are just bits and bytes that somebody can take on a computer and take them away. These are something that you can steal. And, there's so many examples of where we've been hacked. I have a list here in front of me that's, a dozen different, examples. I'm not going to read them because I think everybody already just understands that there's espionage and there's theft and there's all sorts of hacking of all sorts of different stripes. So, if you think about it this way, we need to amp up our security game, in a huge, huge way, because there's just too much at stake, for what we can do. And we can look no further than just go back in time. The reality is that in World War II, the Germans were awfully close to getting nuclear weapons. It came down at the very, very end. They were trying to solve for a particular problem. The United States had figured out to go one way, and they weren't sure if the Germans had gotten to this problem. Turns out the Germans had a calculation error, and they went the wrong way. And that one way cost them months, which allowed the United States to be ahead. And this is the same thing that's going to happen here, because if you have an improved algorithm, you need to be in front of everybody else because, in some ways your freedom may depend on it. So we need to make sure that the free world wins. So I think that when we think about the security aspects, to say like, how do we win? One way that we win is that we understand what it takes to secure these things. And, what it means is that we need to have it on par with military bases. We need to have it, extreme vetting of who's in charge of these things. We need to have the government involved in it. And the government's got a lot of problems, but it needs to be everybody at once. It needs to have super strong internal controls. It needs to have strict limitations. We need to make sure we understand who's the one doing all these research on it. And we need to make sure that they, are meet certain standards, for sure. I think that we also understand, the perils associated with this. The biggest issues that we would have is, can imagine a world where somebody like China beats us at this, a world where we've got somebody who, has done all sorts of repression of its citizens, extreme environment of watching people, manipulating people, jailing people, and even just social control. And with these sort of tools, social control would be at a level that we just can't even fathom today. So that is a super scary proposition. And I think the other thing that we need to worry about, a lot of times when people talk about AI, they sort of think Terminator, right? They think about some world where robots have taken over. But if we envision computers that are smarter than humans and then race to some super intelligence that we really can't understand, we have to be super aligned on certain key questions so that we know we're being told the truth by these machines. We know that we've got certain parameters where we can be in control, and so because if we don't have super alignment on that, we can have a whole lot of other unintended consequences. All of those topics, you could talk about them in depth, just one at a time. What all that means, what exact security, what exact perils of authority, what super alignment really means. I think that the reality is that we're in a world where we just really, quite frankly, can't screw it up. And so a lot of different people have different views about how AI works. So we have some people that are on one extreme, that, oh my gosh, it's Terminator. And on the other extreme is, no, we should just let it run wild. I think there's some middle ground where we need to talk about AI realism. And AI realism is something different where we say, yes, we're going to harness all these things because there's all these good things that can come through it. But for God's sakes, we got a lot of bad things that can happen as well. And we better keep our eye on the ball, because if not, and this story is right, that could have, bad consequences. So that's my story today. Let me know what you think.